Hello and welcome back to Calculus2. We are starting chapter 7, which is actually Calculus 1. We are going to review the integration, the way you learn it in your Calc 1 class. So we're going to say that we have basic integrals, such as integral of x to the p dx is x to the p plus 1 over p plus 1 plus c. So basic polynomials, sine, cosine, right? Integral of all of that stuff. Integral of e to dx is e to dx. Integral of 1 over x is ln x plus c, and so on. So list of basic integrals. You know this. From 4.9. And then we have u sub, which is 5, and then we have back substitution, which is also 5, a little bit more involved problems. After that, we just have some of the algebraic manipulations and tricks that you can use to solve problems. So splitting fractions, right? That's the next one. Yep. So splitting fractions, or long division, and then completing the square, and the last one would be the multiply by 1. Now that 1 is usually right, some blah over the same blah. Looks like blob. Blah. There we go. So whatever it's required in a problem. Ever seen a mathematical formula like this? It's always the first time, right? In life. What is the integral of square root of x dx? Yeah, so you write it as x to the 1/2 dx, and then you add 1. So this would be a simple problem that you shouldn't be thinking about. You just write it out.
Oh,
what happened? Oh, I wasn't even listening. Which is apparently good. I wasn't paying attention. Alright, so the more interesting stuff is clearly when we have the u sub and so on. So how about sine to the 7x cosine x dx? What should I do? Okay. Very good. U equal sine x du equal dx. See? That's the NASA training right there. No, I mean dx is important. So you see that the whole thing over there is du. So what do we have? We have integral of u to the 7 du, which is u to the 8 over 8 plus c, which is 1 over 8 sine to the 8x plus c. Oof. Look at this awesome problem. 0 to 3 pi over 8 of sine of 2x minus pi over 4 dx. Which method should we use? What's U? Excellent. Because you can integrate sine U, right? So all of this mess needs to be U. And what's the derivative? See? Didn't go to NASA. dx. You don't have the 2, so we have to fix that. Now you do have a 2. It's going to be 1/2 integral sine U du. And now we have to figure out these limits. So what happens with limits?
You have to put them in terms of here.
Very good. And in this case, we don't have to go back to x. So plug in 0. Right, u1 will be 2 times 0 minus pi over 4. So negative pi over 4. And then u2 is 2 times 3 pi over 8 minus pi over 4. These guys cancel, you get a 4. So you get what? Very good. Pi over 2. You can do it. You can do it. You can do it.
I talked to that kid.
Do what?
I talked to that kid.
Why?
I think it's kind of cool. He said his car broke down, and I was like, the only thing that he could afford right now. So like, and he's like, he was living in Somerville. It's so loud. I think it's a 2-stroke too. I think he still has to mix oil in the gas when it goes to the gas station.
Oh. No, I thought that he wanted it actually to sound like that. Yeah, that's why I asked why.
It's like a tiny little engine. It's like a changeover.
Oh, then it's understandable in that case. But yeah, the other way, like immediately, why?
You purposely take out the muffler.
Exactly.
No, since the engine's so small. It's a price for the price for the chainsaw. What? So what was the final answer?
Oh, what's the integral of sine?
Maybe.
There we go. And don't forget over 2, right? So we have negative 1/2 in parenthesis cosine pi over 2 minus cosine. I'm just going to ignore the negative because I know that cosine is even function and this negative doesn't matter on pi over 4. So we have negative 1/2. Cosine of pi over 2 is very good. And then cosine of pi over 4 is nice. Perfect. We all good? Ooh. I think you're gonna love this. Wow. E to the 2 square root of x plus 1 of square root of x dx. This is what awesome problems look like. done. Period. The way you did it, it requires another U sub, so you can't do it. From there, you go another one. Your problem is much worse. That problem is far worse than what we have. Yes. So we have. All right, let's take a look at this problem together and then move to the next one. So another U sub. U equals 2 square root of x plus 1. Du equals 1 over root x dx. Because it should be 2 over 2 root x, right? But then 2 is cancelled. So now, there's your du, there's your u. So it's simplified into this, which is this, which is this. Done.
So you need to require 2 U substitute. And in that,
Let's take a look at some of the spicier problems. So, what's happening here? 1 to e squared of ln squared of x squared divided by x dx.
So what you can do is you can bring this 2 out to the front, because that's just going to cancel its log letters. But you have to remember to square it half because the next log is square. So this is only the same to mark it as like 2 log x squared. This is the same thing as that. But when I square this, that makes me 4. That 2 is just uses. So now I have like this is 4 natural 4 natural squared is 2.
All right, so what would be the first step here? Yes, but what did it become when it took it out? It's a 4, yeah. So if you remember from writing sine squared x is the same as sine x squared, the same thing goes for ln. Ln square of a heart is the same as ln heart squared. So this square belongs to the entire ln. So it is ln x squared squared x dx. Now, when this one, using the formula, I was writing limit, ln x to the p is p ln x. When this one jumps in front, the square will make it into a 4. So, this becomes 4 ln x squared over x dx. From where it should be clear, u equals ln x, du equals 1 over x dx, which is what we have. And then the rest should be smooth sailing. Kick the 4 outside, integral of u squared du, and we plug these limits to convert. 1 plugged into ln x gives us 0, and when we plug in e squared, we get 2. Wow, look at that. Like, if you don't like this transformation, you have no emotion, all right? To go from that integral up there into u squared. So it's 4/3 u cubed from 0 to 2, which is 8 times 4, 32, over 2. Ready? Nice. So this square goes on the outside of the ln. And this square goes in front of the ln, but it's still trapped by these 2. That 2 squared becomes the 4 outside of the ln square. Perfect. Nice. Over 3, that's what I said. Pay attention. Look. Clearly says 3. Alright. We'll talk about it. Splitting fractions. This one is fun. This one is really fun. It says splitting fractions, so go ahead, split fractions. X squared plus 2 divided by, sorry, x plus 2 divided by x squared plus 4. Wow. Time flies when you're having fun. 2 minutes left. Okay, let's take a look at this problem. Then you guys try the other groups at home, and we can take a look at those at the beginning of the class on Wednesday. So split the fraction. It says, right, what to do. So we have x over x squared plus 4 dx plus another integral 2 over x squared plus 4 dx. So we have two of these guys. The first one is u sub, clearly, right? Because you have x squared and then you have its derivative x. So that's great. What do we do for the second one? Nope and nope. Yes. Tangent inverse. And this is why you have to memorize it. Otherwise, you are doomed. Let's take a look at this. So the first one is the u sub. And for that one, we have that u is equal to x squared plus 4. Du is equal to 2x dx. I don't have a 2, so we'll make one up. And that's going to be 1/2 integral of du over u, which works out to be ln, as you said. And the second one is plus 2 times, and this one is, you just need to know it. It's, you know, it's what it is. So it's going to be 2 in front, and then the rest of the stuff is 1/2 inverse tangent of x over 2 plus c. And then these 2's will cancel. You need to know that the formula for this is 1 over x, well, integral. I'll write the formula when I finish the problem. So now it's 1/2 ln u, which is x squared plus 4 in absolute value, plus inverse tangent x over 2 plus c. You do not need absolute value in this case because x squared plus 4 cannot be negative. So you can ignore it, but, you know, for the good measure, just always try to put it there. So now, for those of you who forgot the inverse tangent formula, it goes integral of dx divided by x squared plus a squared. And that's going to be 1 over a inverse tangent x over a plus c. So observe that there is 1 over a in front, which is where I got this 1/2 from. And also notice that you have a 4 over here. If you have a 4, that's 2 squared, which is the reason why it's divided by 2, which is that a. And that's it for now. I will see you all in 2 days, or if you stop by office hours, I'll see you sooner. See you later.